Today's topic is going to be what is called limiting reagents. And limiting reagents, as it turns out, are really not that difficult to deal with. It's like doing two stoichiometry problems in one problem. And so let's talk about what a limiting reagent is, and let's talk about how to solve problems involving limiting reagents. So let's define it first. Now, a limiting reagent is going to be a reactant that is going to limit how much product can be made. And the way it limits how much product we can make is it's going to be completely used up in the chemical reaction. So when it gets completely used up, that stops the chemical reaction. We can't continue a chemical reaction if you don't have one of the reactants. It's gone. Now we also are going to have, what we need to identify is what is called an excess reagent. Now an excess reagent is a reagent that is not completely used up in a chemical reaction, and before we had said that that was in excess and we just kind of ignored it. Now we can't ignore it anymore because we don't know which one is in excess. And here's how to determine if you have a problem that's a limiting reagent. Usually, if you have a problem that's a limiting reagent, not always though, there's going to be two known values or two known quantities. So if you see a problem with two known quantities, there's a good chance you have what's called a limiting reagent problem. So let's jump right to it and get to a limiting reagent problem, and you'll see what we mean by this. Okay, so in this problem we have a balanced equation given to us. We have C3H8 being reacted with oxygen gas to form carbon dioxide and water. Again, a combustion reaction. C3H8 is propane. The white tanks that you might see under a barbecue are the white tanks that you might see in somebody's backyard if they have propane gas that powers their stove or their gas heater or something like that if they live out in the country sometimes. So let's get right to it here. So we have 25 grams of C3H8 are reacted with 50 grams of O2. We're being asked to calculate the mass of water in grams that will be made. So first off, we have a known quantity of 25 grams of propane right here. And we also have a known quantity of 50 grams of oxygen right here. Because we have two knowns, this typically identifies this as a limiting reagent type problem. And what we're being asked to find is the mass of water, and of course we're going to find that in grams. So essentially, this becomes two stoichiometry problems. So what we're going to do is we're going to take each known individually, and we're going to do two problems. So we're going to start with 25 grams of C3H8. That's our known, that's one of our two knowns, and we're going to go ahead and do a conversion to our unknown, which is grams of water. That's our first stoichiometry problem. Our second stoichiometry problem is we're going to take our second known, which is 50 grams of oxygen, and we're going to do a different stoichiometry problem, but we're going to go to the same unknown of grams of water. You see, we went to grams of water in both cases because that's our unknown, and we're using two separate known quantities. Okay, so let's go ahead and do the stoichiometry problem. So if we're going to grams, we know that our first step on the mole road is going to be 1 mole over the molar mass C3H8 here. And I have to calculate the molar mass of C3H8, 3 carbons plus 8 hydrogens. Okay, so I calculated the molar mass of C3H8, and I've got 44.11 as our molar mass of C3H8. Now it's time to go around the unknown over the known. So water is my unknown, so I'm going to write that right here. And C3H8 is my known, and so I'm going to plug in coefficients. So it's a 5 from the balanced equation right there to 1 ratio from the balanced equation right there. And then the last thing I'm going to do to finish this all up, I'm going to punch in 18.02 grams, which is the molar mass of water, to go back down the road to moles, or to grams, excuse me, over 1 mole of water. And so I'm just going to multiply this all out and get an answer here. Okay, I just noticed a mistake that I had made here. We need to change this. The coefficient right here for water is not 5. I was looking at the oxygen gas. It's actually 4 from the balanced equation because it was right there. So easy fix though. So I'm going to run this through, and I run this through and I get 40.85, and we're going to call that, we'll round it off to 1 so we call it 41 grams of water made. Now let's just hold on to that problem and see what comes of it. Now we're going to go back down to our next problem, and we're going to do a grams to grams, 50 grams of oxygen going to grams of water. So I'm going to do 1 mole on top. We're going to do the molar mass of oxygen. It's 32 grams of oxygen for the molar mass. We're going to do our unknown over our known, with water being on top. We'll get the right one this time. It's 4, and then the oxygen is going to be 5 O2s. as our unknown, finish it all up with 18.02 grams of water over 1 mole. And so let's run that through our calculator and see what we get here. Okay, so I'm coming up with an answer of 22.53. I'm going to round it off to 2 sig figs. We'll call it 23 grams of water. So we have 2 answers now. Which one is the correct answer? Well, because this is a limiting reagent problem, the smaller of the 2 answers is going to be the amount made. So down here a little bit further, oftentimes they ask us a couple questions and it'll say how much water is made. Well, it's going to be the smaller of the 2 answers, 23 grams of water. Because the greater of the 2 answers was 41. Now, but that'll tell us something. So we're also being asked down here to identify who is the limiting reagent. Now, whichever reactant makes the smallest amount. Now, this is the smallest amount, but this is not the reactant. The reactant is who your known is. This is the reactant here. So whoever makes the smallest amount, this is going to be our limiting reagent. So we would say that oxygen was our limiting reagent. So what happened in this reaction is oxygen ran out before propane ran out. And we know that because it's made the smallest amount when we did the stoichiometry. Our excess reagent is going to be our reactant in the greatest amount, the reactant that made the largest amount of product. Okay, so we're going to say that our excess reagent is C3H8 in this case. And so that is how we do a limiting reagent problem. We identify 2 knowns that are given in the problem. That tips us off that it's a limiting reagent problem. We do 2 stoichiometry problems. And then we just compare the answers at the end. The smallest answer gives us the amount made and the reactant that's a limiting reagent. Our greatest answer just tells us that that's who the excess reagent is. That's who is present in the largest amount. Okay?